Time-sensitive applications require quickly responding to an event. Think of playing a video game and shooting at a target. You want the instant that you shoot at the target for action to appear on the screen. Now, problem is there are three sources of latency for time-sensitive events in any typical general-purpose operating system. The first source of latency is what is called the timer latency. That is coming because of the inaccuracy of the timing mechanism. For instance, the timer event went off at this point, but the timer interrupt actually happens only here. That is, this is the event that should have resulted in an interrupt, but because of the inaccuracy of the timer, there's a latency between the point at which an event happened, an external event, and the point at which the timer goes off, indicating that external event. And this is primarily coming up due to the granularity of the timing mechanism that's available in general purpose operating systems. For instance, periodic timers tend to have a 10 millisecond granularity in Linux operating system. So that's the first source of inaccuracy or latency for time-sensitive applications. The second source of latency is what we call as the preemption latency. And this is because of the fact that the interrupt could have happened when the kernel was in the middle of doing something from which it cannot be preempted. For instance, the kernel is modifying some critical data structure. In that case, it may have turned off the interrupt, and therefore, even though this interrupt went off at this point, the kernel cannot be preempted until this point. That may be the second source of latency, or it could be that the kernel itself is in the middle of handling another higher priority interrupt, and in that case, this timer interrupt is going to be delayed. So this is a second source of latency for time-sensitive applications running on commodity operating systems. Okay, finally, the timer interrupt has been delivered to the system, and now the scheduler can actually schedule the process that is waiting for this timer interrupt so that that application can take the appropriate action for this external interrupt. But wait, there is another higher priority task that's already in the scheduler's queue, and therefore the app that was waiting for this timer event cannot yet be scheduled because of this higher priority task that has dibs on the processor at this point of time. So this is the third source of latency, that is the scheduler latency, that is preventing this external event from being delivered to the application that is waiting for this particular event. Now finally, the high priority app is done, and therefore now it is time for the app that is actually waiting for this event. So this is the point of activation of the event app, that is the app that is waiting for this timer event. So you can see that this is the distance TA to TH. The difference between TA and TH is the event to activation distance. The event happened here, but the app that can react to this event only gets scheduled at this point, and this is the latency that is coming in for time-sensitive applications between the actual event happening and the activation of the app that has to deal with that particular event. For time-sensitive applications to do well, it is extremely important that we shrink this distance between event happening and event activation.